Good afternoon, everybody. Thank you for joining us for all of these sessions. This is the last of the material design ones, and we've saved the best for last. Motion is a key part of everything that we're doing, and it deeply integrates into many of the other disciplines that we're thinking about. I'm Nicholas, and I'm here with a bunch of motion designers from across Google. To start with, Ari and I are going to talk about some foundational aspects of motion design, and then Hélène, Manuel, and Gus are going to talk about actually applying motion design to different form factors we've got. It's only recently that motion has become deeply considered in user interfaces, despite a long history in other media. In film, movement has always been used for storytelling, and UIs that appear in film sort of reflect this. They support an overall story arc, but often lack substance. Video games have a similar problem in that they have these very immersive, stylized UIs, but they're very specialized to a specific kind of task. Traditionally, UIs are more versatile, and we see motion applied there, but it's often like a superficial layer applied very late in the process. So when we were thinking about all this, we asked ourselves, how can we use motion to truly improve UX? In the session yesterday, we talked about using motion to provide meaning, particularly taking user actions and connecting them to the events that follow. And this is sort of the nature of stories that show up in our UIs. Every app and feature and action tell a fragment of a story that propagate throughout the day and explain everything that has happened. Interaction design is also sort of informed by motion. In this album example, you can sort of see the sliding up and down of the album, and the ability to pull on it affords the pull gestures that can show or dismiss it. For this reason, we like to try to consider motion as we're trying to do the interaction design, to say, how can motion be used to indicate what is possible in these places and refine it down so it doesn't have to be as complicated. There's one other variable we like to consider when we do this, is the user. In all of our stories, the user is the driver. And for that reason, we base as many transitions as we can on the user's touch, giving custom responses to every single gesture. This is why we liked the notion of an advanced material as the thing that we build all our UIs out of. The touch ripples and this sort of magnetic attraction of it to your finger reinforce the fact that the user is causing these changes. We want it to feel like you are the one giving life to the UI. This doesn't relate only to a single control, but actually to transitions that happen elsewhere. In this slowed down version, you can sort of see that the touch can affect other controls on the screen in a cascade of different delays that makes it feel like they're all tied to that original event. And the purpose of this is actually simplification. By hiding things inside of this energy wave, you actually can have a lot more detail in something that feels very simple and has a very clear cause. This combination of meaningful motion and user-initiated change are two core principles in our work. And they represent a continual dialogue between the user and the system, and a way of teaching and training. It's really hard to get this right. And we really want sort of the essence of realism, but without all the extra baggage that's associated with it. Ari is going to go into a little bit more detail about how we accomplish this, taking elements of traditional animation and building upon them.
So Nicholas talked about telling stories and the dialogue between the system and the user. And there are really three main areas that drive the motion language for material design. And the first is familiarity. So we all live in the physical world and are grounded in reality for the most part. And motion in our UI is really key to support that material metaphor and bring that familiarity to our user experiences. So our environment is a shared stage, and all of the action takes place there. And there are visually consistent shadows across platforms that provide a visual indicator of the layering as well as the separation between surfaces. And this environment is proportional and bound to the device that you have. So for example, the thickness of your phone. And to that end, we want to make sure that we avoid extreme motions like camera zooms or large rotations that break that environment and take us out of the experience. We also represent surfaces as solid objects that can be directly manipulated. So we use motion to express material's special properties. It can split apart or join back together without tape and dynamically transform and rescale. We can also use changes in opacity when transitioning to or from high speeds to imply motion blur and avoid fading in or out in static states to maintain the feeling that the paper is solid. We also really want to use motion as an affordance and express the transfer of energy from the user into the system, and use this motion to tell the story of how that input propagates and resolves across the system, whether there are hard constraints or forgiving boundaries. All of these are familiar indicators that help us understand how objects can be manipulated. Motion should also be responsive and fast. There's no need to bounce because the material is precise and arrives precisely and smoothly at the target. We have a set of animation curves that you've seen across many of the examples, and those are incorporated directly into the framework. And you can also customize those curves with the new path interpolator in Android L. Choreography is how we guide our users through the experience with thoughtful and consistent motion. When transitioning between spaces or activities, we want to use motion to complement the spatial model of your app, and consider motion and the articulation of these surfaces in the first place when designing how your app is put together in space. Beyond the acceleration and deceleration of objects, we can also express character by the path that objects move along and using curved paths. And natural motion tends to follow an arc, for example, throwing a baseball through the air or the path of a skier down the mountain. And we can apply these ideas into our transitions to make them feel less mechanical than when they are constrained along a straight path. And here you can see this dynamic arc can create fun paths to or from any position on the screen. And you can do similar things in Android L by now supplying a path into the ObjectAnimator. So in addition to the path objects take and the character of their acceleration, thoughtful timing of actions is critical to building meaningful transitions. We want to sequence actions to guide a user's attention around the screen or draw their attention to promoted actions, build understanding of the changes that are occurring, and indicate individuality or grouping of elements through synchronized motion. And in addition to familiar surfaces and coordinated motion, craftsmanship is really the manner in which all these principles come together to create a really compelling experience. And attention to detail and a well-considered motion at all scales can bring delight and clarity to your users. So at the largest scales, we want to create transitions that connect the user's action to the resulting change. Motion can bring clarity to the changes in context and improve the understanding of the relationship between different spaces. And animation at smaller scales can tell a story when space is limited. For example, these micro-transitions can give cues about the changes in state or reinforce functionality through motion or drive discoverability. And these principles around familiarity, choreography, and craftsmanship have really been the foundation of a lot of the design work we've been doing recently. And now Hélène, Manuel, and Gus are going to talk a little bit more about how we've put these to practice in desktop, handsets, and wearables.
I'll be diving into detail about the ways we've been exploring the loading experience in ways that alleviate the wait time. So loading, an often overlooked but an extremely common occurrence, is an opportunity for consistent control across different contexts. We started off by combining a refresh icon and a loading spinner for a seamless and simple correlation. Spinner is the original activity indicator crafted in detail with an organic pattern. Playing with how dynamic colors can complement the whole system and framework, and in this scrolling instance, spinner is paired with an ink splash inspired by the touch ripple effect to indicate an initiation. Our suite of progress and activity indicators, circular or linear, are designed with a synchronized cadence. Whether it's a swipe down to refresh on mobile or opening a message on tablet, the acceleration curves and rotational rhythm are choreographed to follow the same organic pattern. We've also thought about how these can be tailored to a variety of uses. In this Chrome OS update instance, we thought about how the indicators can behave like bookends for distinct beginning and end. A field of color marks an initiation, and an equally dramatic ink splash punctuates, a marker of completion. On top of all this, we thought about how an image would load, and we were inspired by the way photographs are exposed onto paper and developed in a darkroom for a natural and familiar process. We've broken it down to 3 basic phases: opacity, exposure, and saturation. The image would fade in at a low contrast exposure, followed by a full color saturation. Form factors with larger surface areas are the ideal places to pronounce this type of image treatment, such as logging into Chrome OS.
Thank you. Hello. So Hélène showed you a Chrome OS example, and I'm going to talk to you about some of the way we use motion on Chrome across desktop and mobile. OK. So in the case of a desktop or laptop OS, we're dealing with many windows on the screen. And depth is key to ensuring users feel in control of their experience as they change applications and kind of manage their experience. So here, we're using material shadows to communicate quite a bit of depth there. Now see what's happening. The UI is actually not being scaled up, even though it looks like it's coming closer to you. Simply by using the right curves and the appropriate durations and the right properties on that shadow, you create this nice, crafted, smooth transition. We've all seen shadows like this. The fact that it's nicely transitioning like this creates a great continuity between the states. Moving on, this is Chrome OS. You guys know Chrome OS, Chromebooks. In Chrome OS, we have an app launcher. And this app launcher has this feature now that allows you to group applications. On Android, you can do that too. Now, on Chrome OS, the app launcher is already a floating box. OK, folder usually opens up as a popping box as well. We don't want to do that. We don't want to open a floating box on top of a floating box. So in this case, we're using material ink and material response, where ink is shrinking and growing and creating this nice ink bubble metaphor for a folder. And so you see the same bubble kind of appearing, disappearing, and throughout the different states that you're going through as a user. It creates this familiar thing there. It's really nice. Next, let's take a look at a Chrome for mobile prototype. Here, we're looking at finding a way to transition from very different states. See this right here? That's a very different state from this one. All these icons are there, and then they're not there anymore. And if you just flip a bit in your code, you hide, show, and it's not going to look very good. In this case, imagine the person's touching the screen. Boom. A circle of energy flies out of there and pushes items out of the way, back into the scene. It feels like you're creating the story for the user through choreography and motion. Finally, let's look at the Chrome OS again. Large screens present quite a bit of a challenge. You've seen a lot of examples of smaller mobile screens. Now, making something fly up and down that screen may not be a huge issue. Imagine you're looking at a screen that's much bigger, like 20-inch, for example, or 17-inch, even a 13-inch laptop. You want to avoid forcing your users to scan around, is my window coming to the left, to the right, to the left, and it's just crazy. So one way to do this is exploration. We're looking at ways to go whoops, have very short animations to show, hey, the window just went toward the close button, or the window just flew from the button on the taskbar, therefore probably opened the application, things like that. So even though those animations are really short, because we're using the right curves and material, and we're very thoughtful about the way things are moving on the screen, you create tangibility and familiarity to animations and communicate those states really well. Now, you've seen really large screen now and challenges and solutions we're exploring. Gus is going to show you similar challenges and solutions for tiny screens like this.
Thank you, Manuel. I just love motion design. I think it's a powerful design tool, and still it can be subtle. And we use that a lot when designing for wearables. So because of its small screen, we don't have space for multiple panels or different buttons for every action that we can take in every screen. And nor we have space for white space. So in order to fully express the material design language on such a small screen, we needed to use a lot of motion design to cover for all those functions and also to make the device fun and easy to use. So right from the start, even before you start interacting with the device, we have added a simple animation that explains the structure navigation of the wearable device. Is a pretty simple one. You scroll up and down to navigate through different pieces of content, and you swipe right to dismiss a content. So even though it's pretty simple, it's just enough to get you started, so you feel comfortable using the device. As you start using the device and you face situations you have never encountered before, motion design is there to suggest how to interact with it. So in this case, incoming call, you swipe one side to accept the call, or the other side to reject a call. We then end up with a very simple stream of cards where we show one content at a time. And so we quickly realized that it was very important to work on the transitions between those contents. So we orchestrated all elements present on both screens. And for example, the acceleration of the card, the crossfade of the background, and the parallax movement in order to make these transitions feel smooth. And actually, we want to feel invisible, because you're going to interact with it a lot of times. We have also brought animations that we are used to in other devices to wearables, not before making some tweaks and improvements. Let's take, for example, the nod animation. So nodding is something that we do every day when interacting with other people. When we are talking to them, we just nod to acknowledge their presence, to give a non-verbal feedback. And it helps to create a friendly environment for a conversation to take place. So we wanted to take this environment and bring it to our UI, and we use that with a nod using a very simple motion design. We have also created a full set of animations that they all cover a very specific function in the UI, but we have crafted those animations in such detail in order to make every micro interaction feel rewarding. So let's take the sending a message, for example. So you have just sent a message using your new wearable, using your voice, without even touching your phone. So that's a pretty amazing task you have just accomplished. So we wanted the confirmation animation for this task to be as awesome as the task you have just done. So we crafted every animation with a lot of detail. And the boot sequence. So we have done a boot sequence that when you start looking at it, as soon as you turn the device on, and you see it running at this high frame rate in such a small device, it immediately suggests how powerful the device is, and it sets the tone of how you're going to interact with it from that moment on. Nicholas?
So these guys gave you a good idea of a lot of different applications of motion, and each is tailored to the specific form factor. I wanted to go into a couple opportunities that we saw while doing all this work. First, use motion to tell your product story. As Gus showed in that, like sending an email confirmation, it was a moment for a lot of personality and had sort of a celebration for an action that was itself pretty impressive. We want you to find moments to make your apps truly shine and focus on those. Beyond that, use the frameworks. The elements will cover many of the use cases you're going to have with animation, with a standard set of behaviors. You want to build on those, but then also pick moments to enhance. So using things like the shared element transitions, which allow you to persist an element from a state to a state, or even between apps, or refining an existing component using theming, or just building upon it, is a much better approach to doing this stuff, where you are spending your time on the most impactful portions of your app. And last, make motion part of the process from the beginning. There's so much stuff that has emerged from us working between motion and visual, motion and interaction, and seeing how those disciplines can build off of each other and enhance each other. It's really critical to get a polished result. Many of you have probably already looked at the spec. The motion portion of the spec is probably the richest and most complicated. It's definitely worth looking at. Ari and the others have put a lot of thought into sort of the underlying physics and behavior of these materials, and there's a lot of detail in there. You're also, please visit our design site and also get in touch with us at the Plus Google Design page. This has been a really exciting project for us, and we've been really excited to share it with you, but really this is the first step, and we have a lot of a lot of distance to go before this is finalized, and we really want to see how it applies to all of your apps. Thank you very much. So we're happy to take QA now. We'll also be up here afterwards if you want to come chat with us.
I had just a really brief question. Your little refresh icon spinner thing was awesome, and is there any way we can have it? Like, is that like just something you guys designed for this stuff, or is it somewhere in Android hiding in a folder?
That is the standard Android progress indicator, so it should pick up theming like any other element.
Sweet, I hadn't seen the arrow part on it. So.
The arrow transition is a customization of it. I'm not familiar with how we actually go about doing those things, but...
All right, well, it's sweet, so thank you.
Thank you.
Hi. We've seen all those animations, and they look really amazing. When I look at that and try to think how I would do that with the current Android API, I feel like shooting myself. I've seen some of the presentations for the new APIs that are coming out, and I assume that all that animation is going to be much easier to do now with the new APIs.
Yes. Yeah, we're making a lot of progress in that direction. So, for example, like moving things along curved paths, the ObjectAnimator. I'm a designer, so I may not get it totally right, but the ObjectAnimator can accept a path, so you can animate X and Y concurrently, create on a spline path, as well as the path interpolator. So you can apply customized acceleration, deceleration curves with cubic Bezier, and pretty much the same format as you would with the CSS.
Okay, thank you.
Hi. In the beginning of your talk, you showed how elements don't need to bounce because they just arrive at their destination perfectly on time. But in the Android Wear, you showed how the red circle G kind of bounced down then out, like in its not animation. So how do you balance those different animations and when to use them or not?
Okay, so I think the bounce animation is a different and specific animation to make the user feel that the feedback is a visual feedback for the user input. So for all other animations, we do not encourage a bouncy animation. I would not count the nod animation as a bouncy animation. It's simply a movement, a natural human movement that we incorporate into the UI as a feedback.
Gotcha, thanks.
I'll just add on to that for a lot of the transitions that we're doing, we're really perceptive to motion. So having secondary motion or really, kind of like bouncy stuff sometimes can draw your attention to things that you don't really want people to look at.
This is a personal obsession of mine, so I'm going to go into a little more detail. We like to think of this like technologically advanced material as something that is driven by the system, and the system understands physics, and it can understand how to place something exactly where it needs to be and not like wobble as it hits there. But at the same time, it needs to be very responsive to the user. So if the user is pulling something past the bounds where it needs to be, to just simply stop would be almost hostile. We want it to accommodate the user, but in the times that it's moving things, to also land them perfectly. And so it's balancing the two of those things to get the right feel, as well as the right amount of sort of forgiveness when you pull past bounds.
Cool. I'm a UX designer. When I saw your motion design talk on the schedule, I was so happy. Not many conferences have a motion design talk, so I'm so glad you had it. So I have two questions. One question is, what tools do you use for prototyping motion? The second question is, your decks are amazing. And I'm curious to know what tools you're using for presentations.
Yeah, I think, well, a lot of our motion designers use After Effects for just some initial studies, but of course that can only get so far when so much of this motion is tied to the interaction and how it feels. So there's kind of that diminishing return as you go past the point to get an idea of like, okay, this is a direction that feels good, and then we really try and start working with engineers and prototyping to kind of like start seeing it on a device and feeling it to know if that's actually a right decision.
I'll jump in and just, can you hear me? I'm going to add one more point. So all the examples I showed, I'm a UX designer, but I like to code things to try them out. I love to kind of push the browser, see how fast I can render stuff.
Right.
In any case, all the stuff I showed were actually video, QuickTime, like screen recordings of interactive prototypes I built using just HTML stuff, also Polymer. I really enjoy doing that. So like the window control that's coming in now, that was custom element in Polymer I built. But yeah, HTML is I found great because then when you communicate these animations to engineers, like they can look at your code, or you can just copy and paste your variables, and they're like, oh yeah, that's the curve. You know, like it's pretty, it talks to them really well. So, but different designers work differently. The After Effects tool is really awesome for doing a lot of things too. So. Yeah.
And even basic blocking of motion, I think, is very effective, particularly if people are using sort of the standard curves. As long as you're sort of explaining how things move from state to state, it's more than enough to understand. It's just think about state to state rather than just sort of assume that it's gotten there on its own.
Right. Yeah. Cool. I'll also add that motion design has been a really interesting point in the process of developing the system and apps, where it really forces UX designers to work with engineers to kind of like get these ideas and make sure that those kind of concepts are carried over into the final product. So it's a great opportunity to increase collaboration and also help build some understanding on each side. So as a designer, I'm starting learning more about XML, so that way I can tweak stuff myself and make sure I pass along the right kind of information, also take the right kind of considerations when I'm making designs.
Thanks.
Hi, you guys mentioned using the frameworks, and so my question is, if we're trying to design an app that works in HTML and on Android and trying to make the look and feel be obviously as close as we can, say loading an image or progress like you guys, the examples you guys used, how much of a framework is there? I mean, are you guys focusing on trying to put the same look and feel for motion into these different frameworks, or are we still at the stage of sort of wireframing it and handing something over to our HTML guy and our Java guy and saying, figure this out? Or are the frameworks working on giving us more common tools between this so that our image loading looks exactly the same between an Android app and an HTML app?
We are doing our best to coordinate the appearance and the behaviors across the platforms to be highly consistent, if not identical. Things like the standard controls, like stuff like the ripples that you see on stuff, on elements as you tap them. Like, we've been very concerned with making sure that the same formula or logic is used for the way they move, so that they are as close as possible.
And we're talking about Polymer framework here? Okay. All right, great, thanks.
So you guys talked about the continuous motion and things not stopping immediately and things like that. Have you taken a look, or has it changed anything? Android's list view, for example, when you reach the top, it's always just stopped. Is that something that you're looking at changing, or how do you look at that from a motion perspective?
We're continually iterating on that class of animation. Like, we're looking at how refreshing works and how the ends of controls work with loading more content. That's something that we're still working on for the final L and trying to get that all nailed down.
Cool, thanks.
Hi, my question is about the process. I'm just curious, what kind of decisions do you have to make while finalizing the design, and how difficult is that, and what are the possibilities you're looking at, and how do you finally narrow down the details of the motion that you're creating?
Well, I think I can answer part of that, but Nicholas talked a bit about how motion design, really trying to promote that as a peer to visual and interaction design, and really integrate that throughout the whole development process. And I'm sure you've found, many of us have been in situations where you go from, you get some wireframes or you get some visual designs, and these things have been done in sort of a sequential process, and then you say, okay, we need to make a transition from this state to this state. And you're like, well, that might not actually work because this certain transition or this kind of motion wasn't really considered at the point. So you kind of get a bit of churn there. So that's why we're really trying to kind of make sure that when you're thinking about interaction, and it really helps with the whole material metaphor, because sometimes you can actually just take some paper and think about how would these surfaces actually articulate against each other, and how would I get from one place to another, very, very lo-fi prototyping ways. So, trying to just make sure that you're thinking about the motion if that's part of the transition or part of your app throughout the whole process.
And engaging with engineering early too. That's one of the things we realized. Just, you need to sanity check many of these things. These guys make some crazy aspirational stuff that, like motion blurs and other things that are just not feasible. So just getting a sense of what is actually possible, and then refining those animations, like within the bounds of what is possible.
Regarding the part of your question of how to select the best motion, sometimes we make different versions of every animation, and you might think a lot about it, but once you see it, usually on the device, it starts to feel right, and there's a lot of decisions that you simply feel that it's the correct and more fluid and faster way to make a transition.
Okay, so a lot of testing involved, I guess. Yeah.
Yeah, if you have user testing going on in your team, everybody can look at that, the numbers, and see how it improves as you iterate stuff. But I like the point of starting early. It's very important, like the Chrome stuff I was showing, like the visual layout. Everybody was talking together on the team, and very early on, like, stuff started moving around, and this is too much, this is too little, and we got a chance to look at it early on, and just iterating a lot, and that communication flow between the different people on the UX team as well as the engineering is super important. So they feel included too. And, you don't dump something on their lap that's like super outrageous. It may be the right design, but and that's more like team dynamic type of strategy stuff, not really UX. But
and also kind of to when Gus was talking about the nod, and even in the visual design talk about thinking about the brand and your color story, think about the character and maybe the personality of your app. And if you kind of understand that app is like a person or a personality, then that's a really good bar to kind of keep your motion tied to. So if it's fun or familiar or serious or quick or assertive, whatever it might be, that's something to help keep it consistent across.
Okay, so there is some logic to it, the way you come to decisions.
Yeah.
Hello. You show examples of this material design being applied like to phones, watch, laptops. Have you also considered auto, and what could potentially be different there, given the fact that the user just glances at the screen of the car and could potentially miss some of the animations, or maybe it's actually better to highlight what are the most important actions? Have you given any thought to that?
I don't think any of us have worked on car.
No, I think, no, none of us have worked directly on the auto stuff, but I think what we're trying to express with the principles is that there's a real range of possibilities, and really understanding your target audience. Just like the personality of it. For example, on a car, you don't want to have lots of motion that could be distracting. You want things to be really concise. Same way on the wearable, where you don't maybe have a lot of real estate. Motion is really an affordance to indicate what options there are, how to manipulate the interface. So sorry, go ahead.
These are very focused on sort of active, attentive interfaces. I think on car, the tools you'll see used are going to be more focused on like using change blindness to actually have animations that deliberately hide change so people's attention isn't drawn, or rarely are used to explain hierarchy when you actually are engaged. But there's a whole separate set of things that are probably warrant their own talk.
Yep. You've seen back there the projections. They have all these motion of the UI for the Android Auto. It's pretty neat stuff. Maybe you can talk to people there. They would answer your questions. One thing I would say, having worked on car stuff before, is like not only there's a problem of like not distracting the user, which is very important, but also the screens they use in cars. The reason why they're not as fancy as tablets because they're really rugged devices that are automotive grade, and so they have to deal with a lower frame rate often, and the touch response may be a little slower. So there's a lot of challenges there, and the animations have to be designed a little differently. Although what they show there is pretty cool on the big screen, so go talk to them.
Thank you.
Hi. When it comes to actually practically implementing a lot of these animations, how well? Two questions. One is, how well do they gracefully degrade down to something like a gingerbread device? And then how backwards compatible are they with something down as far as like ICS or something?
Yeah, I don't. I wish we had one of our engineers to talk really about the full backward compatibility story. But I think there's a lot of new APIs in L specifically to enable this kind of stuff. For example, like the native shadows and the the ObjectAnimator with paths and the path interpolator. I think there's a similar story to the visual design, that if you design for kind of the high end, it's easy to kind of pare back and start thinking about, okay, what elements of this transition can we degrade for devices that don't have some of those features.
And I think one other important point is to be conscious of the things that are only indicated or afforded by motion. Like it's often better to have additional affordances. We generally couple like the dimensionality with motion to indicate that this thing is movable. Allow it to be capable of falling back on something that's a little bit more static.
Cool. Thanks.
I'm going to ask a somewhat antagonistic question just for the sake of discussion. In the last, I don't know, since the 1970s, people have been talking about escaping the metaphor of paper on the internet and using more dynamically generated content and not being limited by the real world. What are the weaknesses of the paper metaphor? What are the weaknesses of material design as people are trying to push other ideas forward?
I think the things that we have run into is when we over-apply elements. Like I think one of the examples from visual design was like when everything's on a card. It's too easy to fall into the trap of like, I want a great deal of contrast between different elements. This is also true of motion. It's pretty easy to try to animate things that aren't the right thing. One of the key drivers of the motion we've been doing was deciding how you're going to manage the user attention. Like you want to move things in such a way that your eye catches the last or the first thing, but very deliberately chosen. And that we avoid having things moving counter to that or creating sort of disturbances. Yep. She asked about how the system itself might hold back other ideas. I'm trying to think. Generally, we've been trying to be so flexible about the amount of theming and structure in this stuff that it is actually looser than many other systems, even though there's a lot of baseline elements you could use. The thing is that generally when you run into a problem with the system, like these are intended to be guidelines. They're not intended to be end-all be-alls of what it should be. They're starting points. And part of what we're trying to do with Polymer and with Android is establish a baseline level of quality that you start with and then can build upon. And as we see people applying their brands to apps or just sort of building them out, we want and encourage them to take this and build on it and make something a little bit more extreme or tailored to whatever their specific use case is. But this is sort of the baseline set of elements you start with.
And also, we've tried to really be considerate in how broadly they can be applied, because as you saw in the keynote, there's a lot of different platforms being announced, so a lot of different form factors, and each one of them has their kind of their own nuances for what kind of depth and what kind of surfaces that we want to represent. So I think as we continue to evolve those platforms, I feel like we've set up a system that has enough kind of flexibility and dynamic range that we can grow on it and expand it to accommodate those.
I thought something. If the illusion gets broken, it's a big problem, and this can happen in many, many ways. Like dropped frames due to if an animation should lose frames, or the perception of this thing as being realistic is violated. That is one of the ways that you recognize these as failings in the UI, and that's why we're trying to avoid things like jump cuts, or trying to focus on very specific tailored animations that aren't part of a larger system that's not totally resolved. Having people's sort of primal understanding of dimensionality and shape relies on it being internally consistent and not overbearing. And so trying to balance how much to do and avoid the times when it's too much or it falls down.
And we'll hang around if you want to chat some more.
Any other questions? We'll be up here if you have anything else. It was good to see you all. Thank you very much.